Now let's look at a warehouse location problem. Here's the setup. A Spanish telephone company serves 7 cities labeled A through G. They need to set up warehouses to stock products such as new phones and spare parts. They would like to find the minimum number of warehouses that are needed so that every city is within 100 minutes driving time of a warehouse. Warehouses can be located in any of the 7 cities, and the driving distance between them are given below. Of course, it's also measured in minutes. How many warehouses are needed, and where should they be located? So as inputs, here are the distances of each pair of cities measured in driving minutes. Now, here's how the model is set up. There are 7 decisions to be made, and each of them are a binary variable indicating whether to set up warehouses in each of the city. So here in row 16 is our decision variables, 0 or 1. Also, in order to calculate whether a city is covered by a warehouse in another city, we convert the distances into a binary matrix. And you can see the formula is very simple because on the top we have set the covering distance is 100 minutes of driving time. So we just grab each of those numbers and compare to the distance. If it is less than 100, we say yes, it is covered. But if it is over 100 minutes, then we say 0. So it cannot be covered. So by doing this, we establish a feasibility matrix. Let's just say we set up a random starting value. So we're gonna set up in A, B, C, D, and G. Okay, so there are 5 of them. How do we know if each city is covered? Here's how we do. Let's look at A. Okay, the formula is sum product B16 to H16. That's our decision with the first row of this coverage matrix. So let's see what it does. This is essentially saying, given we have warehouses in 1, 2, 3, 4, there's 5 spots, and let's see how many of them can cover city A. Well, A is covered because there's a warehouse here. D is also able to cover A because there's a warehouse, and according to this matrix, it is within 100 minutes of driving time. Others, no. For example, even though H there is a warehouse, it is beyond 100-minute driving time, so it's not covered. So this is a crucial step. By using the sum product formula, we are able to calculate how many warehouses are able to cover a particular location given a warehouse setup. Now, we want to minimize the number of warehouses, and the goal is to minimize the sum of these 0 and 1s. So, of course, as a constraint, we should say all of this should be greater than 0, meaning that we want all the city to be covered. So let's now move to how to solve this. Data solver. Now, we want to minimize B37, which is the number of warehouses, by changing our 0101 variable indicating where to set up warehouses. And one constraint immediately follows is that they are binary. The decision variables are binary. And the second is what we just talked about. every city has to be covered. So it is greater than or equal to 1. Now, since we are using 0, 1, 0 binary variable, and everything is linear, we use simplex linear programming method. Let's run it. Of course, everything is positive, so we check unconstrained variable to be non-negative. So the problem is setting up, and you will see that Excel quickly reached a solution. This is the advantage of being a linear program, and we keep it here. It turns out we just need 3 warehouses. In this solution, it is in B, D, and G, and you can see that every city is exactly covered by 1 warehouses. So that's a good solution.